Hi, in this lecture, I want to show how to compute three types of median using the statistics library. The first one will be the regular median that we all know of, and then we will compute a median low and median high. So let's get started here by importing the statistics library as stat. Next, I will make use of pandas as PD and numpy as NP. And here I have a list of data from which we will compute the median and the median low and median high, and also to demonstrate what is a median low and median high. To compute the regular median, I just say median equal stats dot median and pass it the list. Then if I want to take a look, I just say median. All right, so it computed the median to be 6.5. Okay, so next what I'm going to do is sort this list and demonstrate how it got the 6.5 before we can talk about median low and median high. So all I have to do is say data.sort. I pass it the sort. All right, now let's take a look at the data. Okay, the sorted data is in order. So you can see then we have an even number of observations. The median will be the mean of the two middle numbers, but the two middle numbers are 6 and 7. So the median is computed as 6.5. Since the data is even, the median low will be the lowest of the two middle number, which is the 6, and the median high will be the upper one of the two middle number, which is 7. If the data was odd, the median will be just that number in the middle, and in which case median low equal median high equal median. All right, let's show what is the median low. So if I say median low equal start that median low, we pass it the sorted data, the data. Let's take a look at median low. Should be 6. All right, next let's take a look at the median high. So median high equals start that median underscore high, we pass it the data. All right, let's take a look at the median high. So median high is 7. So that's how median low and median high are computed. In practice, in real world application, only the regular median is used, not the median low and median high, but they are made available within the statistics library for cases where people want a median that is in the data. Notice that the median low and median high will always be in the data, whereas the median, if the data is even, the median is just the mean of the two middle number, which is 6.5. Notice there is no 6.5 in the data. I want to make this a little bit complicated by introducing missing values in the data. Let's copy this. We're going to copy the list. I'm going to call it, I'm going to introduce a missing value. So a missing value is represented by np.none. All right, you can write it like that. I like to write it N, capital N-A-N. So this is a constant in NumPy that represent missing values. So if I do that, let me call it, instead of data, let me call it data2. All right, so data2 is NP. It has missing value 1 represented by np.none. All right, let's take a look at data2. So you see np.none translate to none, which is missing in Python. Now let's try to compute the median of data 2 with the missing value. So I will just say start dot median, right, data 2. Okay, it returned a 7. But this is wrong. Why? All we did here is introduce a missing value. Okay, what's happening here is that when there are missing value in the list, we need to resolve that missing value. We need to drop it before we compute the median. We know that the median is 6.5, but by introducing missing value, it said that the median is 7. Let's even illustrate that with trying to compute a median low, where the data still have missing value. So data 2. Okay, again, it says median low is 7. And if we try to do median high, let's try that for completeness. Data 2. It says also 7. We know that this is wrong. So when the list has a missing value, or the data has a missing value, whether it's appended, if we want to use the statistical library to compute the median, then we need to resolve it. We need to delete the missing value from the data before we compute any median. All right, there are two ways of doing that. So I'm going to call it new data. So I will say new data equal x for x in data 2. That's using list comprehension. If the string value of x not equal to none. So all I'm saying is that, okay, give me all element in data 2 where the string value of that x, need to close the parenthesis here, the string value of x is not equal to none. So by doing this, it should give me all the numbers except none. Okay, let's try it. Okay, it didn't like this. What's going on here? Oh, there's an extra parenthesis that I put here that doesn't belong. Okay, so let's take a look at this. Take a look at the syntax. The syntax is correct now. Okay, all right. Now let's take a look at the new data. All right, the new data does not have none. Okay, now if we want to compute the median of the new data, it should be the same as what we obtained previously, 6.5. So I will just say start that median new data. Again, now we are getting the correct value, 6.5. So to really re-emphasize the point here, if we are using the statistics library to compute median values or any other form of statistics, if there are missing values in the list or the data frame for the variable for which we want to compute the median, we need to drop that missing value. Otherwise, we will get computation results that are wrong. Because with the missing value, it doesn't handle the missing value properly when computing the median. So we need to drop it. There are instances where people can impute for, for that missing value, but that's another topic. So we drop it and we recompute the median and we get the correct value, 6.5. Thank you.